Okay.
Hello, everyone. Welcome to Virtual OCP 2020, and thank you for attending. My name is Tuan Zoom. I'm a lead member technical staff at AT&T Labs. Today, we will be presenting the disaggregated scalable firewall framework that AT&T, Palo Alto Networks, and Broadcom have been collaborating on. This is an expansion of the distributed disaggregated chassis that AT&T contributed to AT&T recently. There's a presentation on the distributed disaggregated chassis after this session, if you are interested. Distributed scalable firewall will enable network operators to deploy firewall as software platforms rather than hardware appliances. Then and now I will turn it over to Jim. Jim, please.
Sure. I'm Jim Sugg with Palo Alto Networks, Senior Product Manager. So I'm going to go through the goals and some of the deliverables of the effort that we've embarked on with AT&T and Broadcom. So first and most importantly, the idea is to cost effectively scale using white box concepts, leveraging existing OCP designs. So, and importantly, depending on the deployment model, this allows you to scale firewall capacity incrementally as network bandwidth scales. In particular, you can scale firewall bandwidth independently of network bandwidth. Also allows firewall protection and security services to move closer to the edge, and supports new session-aware applications, leveraging the inline capacity of switching chips such as Broadcom's Jericho 2. So key to this, of course, is openness from both a hardware and software perspective. So what we're proposing is an API and a methodology that will work with multiple firewall implementations and multiple different offload hardware implementations, flexible deployment models, which we'll talk about in a bit. And because it's an open API, customers have independence to choose from potentially a variety of firewall solutions and hardware offload solutions. So as I mentioned, the intent is to leverage existing OCP designs, so servers of 1 rack unit and above, and session offload is something that's based on the capabilities of existing switch chips in the marketplace, Broadcom Jericho 2 being the initial target, but certainly there are other switch chips that could fulfill the role as well. And then because the API will be developed openly, and we're looking for input from both vendors and potential users, be agnostic to the firewall or the hardware offload, the switch implementation. So the API is really key to this, designed to be independent and open, and really focused very tightly on session tracking. So session creation, teardown, and of course, statistics. So don't want to reinvent the world in APIs, but focus it on session tracking, focus it on openness, with the intent that will allow new applications at service provider scale, moving up the stack to layer 4 and layer 7 at very high scale. So the two deployment models, the first is distributed, so firewall and the session offload device in separate enclosures. The advantage of this is that you can have multiple session offload devices, switching elements in the initial implementation serviced by one firewall. And because they're in separate enclosures, obviously, they can scale independently. So the other model obviously would be integrated. That has both the session offload switch and the firewall processor in a single enclosure, likely a 2-rack unit device. Conserves rack space. For some use cases, it's much simpler to be able to have one discrete device. But the disadvantage of this is that, of course, the ratio of firewall processing to session offload capacity is fixed. So those are the two models we're proposing initially. Now we'll switch over to
Okay, so I'm going to go over the proposal of the hardware. So as you can see in this diagram, the blue box, the programmable NPU, would be a white box switching element. And then the red boxes are the scalable firewall. This is in the distributed model. So the firewall element are Xeon or ARM processor. They connect to the switching element via 100 gig connection. And then they're all connected in the back through another switch denoted by the green box there. That allows for the internal control management, and also that's where the API function will go over. And in the front of the white box switching element will be the interfaces to the customer networks that would typically be known as the firewall zones. And if the switching element is a Broadcom chip that has some kind of fabric interface or even different fabric interface, the yellow line will allow this to be connected to a fabric element in a DDC type of scalar architecture. So that's the target design. But this first one we want to focus is on a standalone use case. And then the target is that we would like to be able to connect it eventually into the DDC fabric. And the advantage of connecting it this way is that we already have routers connected with interfaces, and because it's connection through the fabric, we can route traffic to the firewall subsystem and then coming back. This is the eventual target. That's a longer term target. Now for the first use case, first POC use case, we're going to start out very simple with just one firewall element. Start out with a 16-core Skylake D Xeon processor and a Jericho 2 white box. Then we are working right now to define the APIs and the interaction. What is are the key elements that are stored in that yellow table in the switching element, and what is being tracked, statistics and all those information. And I think this brings us to the end of the paper, the talk. There will be a white paper published to go into more detail. And right now we're soliciting API participation in the API specification. And you can also check out the DDC setup in the Experience Center. Thank you.
Thank you.